Lesson 4, Real Numbers and its Subsets. We start by remembering what are natural whole integers and rational numbers. Natural numbers are the numbers that you learn first, the ones that you use to count. That's what they're also called, counting numbers. And they are the ones that start with 1, 2, 3, 4, and they keep going forever. Now, after you learn that, you also learn that 0 exists. So we're going to put 1, 2, 3, 4, 5 also. But we have to include the 0 on the whole numbers. After we know that, we also learn that the negative numbers exist. Now that's also infinite, so we include the -3, -2, -1, and then 0, 1, 2, 3, 4. Now if you notice, they're infinite to the left and to the right, and it's all the numbers that are whole numbers, and then we also have the opposite of the natural numbers. So the -1, -2, -3, -4, and so on. Rational numbers are all of these that we already learned, the natural, whole, and integer, but they also include decimals and fractions. What is important to understand is that the naturals are part of the whole numbers, the whole numbers are part of the integers, and the integers are part of the rationals. But the rationals are also a subset or part of a bigger set, which is the real numbers. Okay? Now, you might ask, why real numbers? Are there any imaginary numbers? The answer is yes, but you will learn that in Algebra 2. Okay? So if we go to the number line, we have 0 in the center, and then 1 unit to the right is 1, 2, 3, 4, and it keeps going, right? And then to the opposite, to the left, we have -1, -2, -3, and so on. Now, any number that is in between one of those could be also a rational number or an irrational number. We're not going to talk about irrational numbers right now, but for example, here I have 0.5, or here I have 1.5, or I can also say that we have -1/2. All of the fractions and decimals are rational as well. Now remember, integer numbers are also rational, so -3 is also a rational, okay? Now we're going to be focusing on fractions and decimals. This is a long lesson, but let's try to go through it fast. You should know most of this is just a review. So when we multiply fractions, remember we multiply top with top and bottom times bottom. So 4 times 7 is 28, and 3 times 5 is 15, and that's it. That's our answer. Okay? This is called an improper fraction when we have a bigger number on the top than on the bottom. Then we have to remember, what do we do with division? In division, we keep the same fraction, the 4/3, but then we change the division sign for a multiplication sign, and we do the reciprocal of the next number. So 8/15, the reciprocal. We change what is on the top to the bottom and what is on the bottom to the top. And then we multiply just as we did before. 4 times 8 is 32, and 3 times 15 is 45. That one is a proper fraction because the numerator, or the one on top, is smaller than the one on the bottom. Now, remember that whenever you have multiplication of fractions, you can reduce, but only in multiplication, never on division, on subtraction, or addition, only in multiplication. So how does that work? Well, if you have the same number on the top and the bottom, then you can cancel because you're dividing by 5 both the top and the bottom, and you get 1. But also, if you have the same factor, so for example, 3 is divisible by 3, so I can divide by 3, and 6 is divisible by 3, So I can divide by 3 and the answer is 2. And also, if it's within the same fraction, we can do the same. 21 is divisible by 7, which is 3, and 14 is divisible by 7, which is 2. And whenever you can't reduce anymore, then you multiply. Remember, this makes your life a lot easier, so do it. Practice and it will become very easy for you to do. All right, let's do this other one that has a division. Remember, a fraction is a division, so I have to pass this first to improper. I always pass first to improper. The way we do this is that we multiply 3 times 3 is 9 plus 1 is 10, and then we keep the denominator. And we do the same here. 2 times 5 is 10 plus 1 is 11 fifths. Now, remember that we can do this by rewriting this as a division or by multiplying the 2 on the outside and putting our answer on the top, and then the ones on the inside and putting our answers on the bottom. And that's it. Pretty simple exercises. In this next section, we're going to review basic operations with decimals. Remember that for both addition and subtraction, we have to align the decimal point in both of the numbers. So we'll rewrite this vertically, and we have to also add a 0 if we want to. It's not necessary, but you can add a 0 there to see that you are adding those two things. And then we add, again with each place value aligned, and that would be our answer. For the subtraction, we do the same. We have to align the decimal point and all the numbers accordingly. And again, we put the 0 so that we remember there's a 0 there. And in this case, we have to borrow. So we'll start by crossing the 1 on the left and giving 1 to this one. So 10 minus 3 is 7. 5 minus 6 is not possible either, so we'll have to take away from here. And then we have 15 minus 6 is 9. Then we don't have enough for the 0 minus 1, so we'll have to go all the way to 4. And the 4 gives 10 here, but then that 10 becomes a 9, which gives 10 here, which also becomes a 9, so that then we can have a 10 here. 10 minus 1 is also 9. 9 minus 2 is 7, and 9 minus 0 is 9. Then we have the decimal point, and 3 minus 0 is 3. And that would be our answer. Be careful when you have to borrow so that you do it in the right way. Now for multiplication, we don't have to align the points. So I'm going to be very obvious here. So I'll just put this not aligned so you guys remember that they don't have to be aligned. Because what we do is that we multiply ignoring the decimals. So we start multiplying. 6 times 6 is 36. 6 times 0 is 0 plus 3 is 3. And 6 times 4 is 24. We leave the space using a square. And then we multiply 1 times 6, 1 times 0, and 1 times 4. Now we add these two. And now we go back and count how many decimal spaces we have. We have 2 here. And we have 3 on the bottom. So we have total of 5 decimal spaces. So we have to move from here 1, 2, 3, 4, 5 and put the decimal point there. So our answer is 6,496 and 100,000s. Don't forget the decimals at the end. Now for division, we have to be careful because we cannot have decimals on the divisor. So what we have to do is rewrite this by multiplying times 100 to get rid of that decimal. But if I multiply the divisor, I also have to multiply the dividend. So when I rewrite that, I'm going to have 603 and 9/10 and divided by 3. Now we can divide that. And so 6 divided by 3 is 2. Bring down the 0. 0 divided by 3, we can't do it, so we put a 0 there. Then we bring down the 3. 3 divided by 3 is 1. And then we have the decimal point, so we have to bring that up. We put it in our answer. And then we bring down the 9. So 9 divided by 3 is 3. And that's our answer. So remember, you cannot have decimals in the divisor, so you have to multiply by a power of 10 to get rid of it. The last section in this lesson is the unit multipliers. Now, it's very important that you remember the different conversions that we have learned in the past. 1 mile equals 5,280 feet. 1 yard is 3 feet. 1 foot is 12 inches. And then this one here is very important because it's the bridge between the American system and the international system. 1 inch equals 2.54 centimeters. And finally, the one we use the most from the metric system is 1 meter equals 100 centimeters. We can also include here the kilometer. 1 kilometer equals 1,000 meters. So that's a good one also to have there. Okay, so let's remember how we do this process. Very easy if you do it in the right way. So it says convert 32 feet to inches. So we're going to start by putting the number here that we are working with, 32 feet. And then we're going to put a parenthesis where we're going to put our unit multiplier. Now notice that the parenthesis is divided in two and it goes down to the next line in your notebook, okay? So 32 is clearly on the top. This part is on the top and this part is on the bottom, okay? So that's super important. Now we think or go back to our conversions and we see that to go to feet to inches, we have to use that 1 foot equals 12 inches. So the foot we put here on the bottom, 1 foot equals 12 inches. Why do I do that? Because these feet units is going to cancel with these feet units. And then we just multiply because they're both on the top, 32 times 12 inches. Now in this level, we don't use calculators, so you don't have to multiply that. You can if you want, but for me, you can leave it like that. Let's look at the next example. It says convert 36 feet to miles. So notice that we're starting the same with 36 feet, but now we're going to go to miles. We put feet on the bottom again because we want them to cancel. But now we see if there is anything that connects feet with miles. And there is. 1 mile is 5,280 feet. And again, when we multiply these two cancel because one is multiplying and the other one is dividing. And our answer is going to be 36 with the 5,280 in the denominator because it's on the bottom here. And miles is the unit that we need for the answer. And that's it. That's all you have to do. It's pretty simple if you follow the instructions as I'm reminding you how to do. All right, now we're going to do the one that goes from the American system, which is the inches, to the metric system, which is the one that most of the world uses. So again, we start with 47 and 25 centimeters. And we want to know what is the conversion that connects these two. What we know is that 1 inch equals 2.54 centimeters. Again, we want the unit that is on the top to be on the bottom as well so that they can cancel each other. And again, when we do that, we have on the top, we have the 47.25, and on the bottom, we have the 2.54. And again, we just leave it like that. You don't have to divide that. You can just leave your answer like that. Now, the next exercise is about in the metric system. So we do the same. 42 meters, we want to pass to centimeters. And we know that 1 meter equals 100 centimeters. And again, the meter on the top cancels with the meter on the bottom. And when we multiply, is 42 times 100 centimeters. Now, you could leave the answer like that, but this is a very simple simplification. So we'll just do it. It's 4,200 or 4,200 centimeters. So the only reason why we multiply here is because it's by a power of 10, and so we just have to move the decimal 2 spaces. In example 4.9, we have to convert from feet to centimeters. So we go from the American system to the international system. Now, we need 2 steps because we don't know how many centimeters are in a foot, but we do know that 1 foot is 12 inches. So we go from feet to inches, and then from inches to centimeters. So we need 2 steps here to get to the answer. And again, in this case, the feet cancels with the feet on the bottom, and the inches cancel with the inch on the bottom, and then we just multiply 50 times 12 times 2.54. And don't forget your units, centimeters. Super important. If you don't put the units, then that doesn't mean anything. You have to say what you are finding. The last one here is to go from miles to inches. So that one is within the same system, the American system, but again, we don't know how many inches are in a mile. So you have to go from miles to feet, and then from feet to inches. Okay? Remember, what is on the top goes on the bottom. So 1 mile, 5,280 feet, and 1 foot, 12 inches. And again, when the units cancel, we just multiply the numbers, and we have to put 4 times 5,280 times 12, and then the units, which are inches. That is our lesson. A lot of examples and different things to remember, but everything very easy. Okay, I'll see you in the next video.